All right, our last video of the summer. We're on day 14, block 3. We are interpreting residuals today. So there's going to be a good amount of math in this lesson. You will want your graphing calculator for this lesson as well. But we're going to start to look at how we figure out the accuracy of our linear regression equation and how we actually use that to make decisions in like a real context. So it says Battle Creek Cereal is trying a variety of packaging sizes for their Crispy Puff cereal. So this is all about a cereal company, and they're using different box sizes to see how much weight the box can hold. So how much cereal can the box hold as we use more packaging. Okay, so we have our data collected up here. So our packaging is our X variable, because that's the part that they control. They're changing the packaging and then measuring how much the box can hold, how much cereal. So that would be our Y variable. So I want you to start by making a scatter plot of the information. So you can do that on your own. See if you can figure out a good scale for the X and the Y variable, plot your points, and then we'll come back together. I'll leave the screen here so you can look at the data as you make your scatter plot. All right, here's my scatter plot. So if you labeled your X and Y axis a little different, yours might look a little bit different than mine, but just look at the overall shape. Okay, it looks pretty nice here. I just spaced mine out so that it's a little bit easier to see, but no big deal if you just did like 100, 200, whatever. But if you can space it out, it does make it a little bit easier to work with. So let's take a look. Describe the strength and direction of the association. Okay, so when I look at this scatter plot, this definitely seems to be a strong association. So our strength, I would say it's strong, and it's definitely positive. Okay, it's also linear. It doesn't ask us about that, but we can add that as good practice. Because remember, we have those 3 sections we talk about with an association. Give an equation the executives can use to predict the net weight of cereal based on the amount of cardboard used for the package. So this is our linear regression, or a line of best fit. Remember, those 2 terms mean the exact same thing. So you're going to use your calculator on your own here, type in your data into L1 and L2, and you're going to select option 4, linear regression, to get the equation, okay? All right, here's my equation. Remember, it's y hat whenever we're looking at a linear regression or a line of best fit, 2.29x minus 132.102. If you're getting something different, I would first double check that you typed in all the numbers correctly. That's usually the issue, just a little accidental typo, so check that. All right, so now let's interpret the meaning of the y-intercept and slope. Do they make sense in the context of the problem? So I want you to try to interpret on your own, because we have talked about that a little bit earlier. So see if you can interpret it, and then we'll talk about if they make sense. Okay, so here are my interpretations. So again, I wrote my slope out. I just used the units here, but you can write weight and cardboard if you want, whatever helps you. But the interpretation, I said the weight increases by 2.29 grams for every 1 inch of cardboard. And then our y-intercept, the box weighs negative 132.102 grams with 0 inches of cardboard. Remember, that's when our x variable is at 0. So the slope seems fine to me, like that makes sense in the context. As we have more cardboard, the weight that the box can hold is increasing. Okay, the y-intercept is where it doesn't quite make sense anymore in the context of the problem. Like, how can the box weigh a negative amount? So this is where like that linear regression kind of doesn't work when you get to things like this. We know that really the box, and by weighs I mean it holds that much cereal, but really it'd be able to hold 0 grams of cereal with 0 inches of cardboard. Okay, so it doesn't quite make sense. But anyway, number 4, it says tell the executives how much cereal a new experimental package that uses this much cardboard is expected to hold. Okay, so now we're using our linear regression equation, y hat equals 2.29x minus 132.102. we're using this equation to actually like make a prediction to tell them how much we expect this box size to hold. So let's plug in that value, 2.29 times 260 minus 132.102, and we'll solve here. For y hat, we get 463.298 grams. So this is how much we expect that size box to hold, how much cereal. Okay, so that's all stuff we've been familiar with. We know this. This is a little bit of a review. Now we're going to get into the new part, and that's this idea of residual. A residual is a measure of how far a prediction is from what was actually observed. Okay, when we find a residual, it's just a calculation, and I usually refer to it in this way. It's the actual value minus the predicted value. Another way people talk about it is the experimental value minus y hat. So the predicted value is always whatever we get from the equation. So this answer that we gave in the previous question, that was our predicted value. We're using an equation to predict how much the box might actually hold. We haven't made this box yet, so we haven't actually measured anything. The actual value comes like from the experiment, like it says over here, or from an actual measurement in real life. So once we create the box, how much does it hold? And then we're going to subtract those values to say, okay, well, how far off were we? So that's something I like to add with residuals. That idea is how far off was our prediction? Kind of how far was the actual equation? Okay, so it says in problem 4, we predicted what this size box, 260-inch box, will hold. And then it actually holds this much. So this is the measurement. Here they built the box, they put the cereal in, and they weighed it. And they said, okay, it actually only holds 355 grams. So what is the residual? How far off was our prediction? So we're going to find the residual by doing actual minus the prediction, or the y hat amount. So in this case, the actual was 355 minus our prediction, 463.298. So our residual is negative 108.298 grams. Okay, and it's fine to have a negative residual. That actually means something in the context of our problem. This problem, it means that the box held less than what we'd expect. Okay, and we'll talk about whether that's good or bad in a moment here. So what is the residual for the 471 inch squared box? Be sure to include units. So we need to go back to our table. 471, the actual amount that it held, this is actual, this is measurements. They filled the box they created and weighed it. It holds 1,020 grams. So I'm just going to make a note, 1,020 grams. Be sure to include your units. So before I can calculate the residual, I need to figure out that prediction. I need to do that first. So I'm going to do that over here. So y hat equals 2.29 times 471 minus 132. Because I don't have that prediction value. I only have the actual value. Okay, I'm missing a piece of the equation. So I'm calculating it using my linear regression. And it's 946.488. Okay, so this value, this is grams, this is the y hat, or the prediction. Either way you want to think of it. Okay, and then this guy over here is the actual value. That's how much it actually held. So let's calculate our residual. Step 2. Our residual will be the actual minus the prediction. So our actual amount was 1,020 minus the prediction equals 73.512 grams. So in this case, our residual is positive. So it's telling us that we're actually holding more than we would expect. So that kind of answers the next one. What is the difference between a positive and negative residual in the context of this problem? So we'll talk about this a lot with our residual situations because it really matters. If you're working in a business and you're doing some statistical analyzing for them, you need to be able to go to the people in charge and say, hey, this is the data I found, here's my residuals, and here's what they mean. It's not really great to just be able to find the math. You need to be able to explain it and interpret it. So that's what we're talking about here. If we get a positive residual, in this case, that means that the box holds more than predicted. Right? Because when we did our actual amount minus our predicted amount, if the actual would have to be bigger in order for it to be a positive number when we subtract. If you get a negative residual, the box holds, less than predicted. Okay? So, you can think about, well, what would a boss prefer? Would they want the box to hold more, or would they want the box to hold less cereal? All right, so number 8, the company is looking at selling a supersized box. So now we have a really big box here to its warehouse club stores. Knowing the residual for this box is 1,005 grams. This is the residual amount. How much does it actually hold? So let's write our equation. Residual equals actual minus predicted. So let's think about the things we know. I know the residual amount. It's 1,005. So I can plug that in. How much does the box actually hold? That's what I want to solve for because I'm trying to figure that out. That's what the question's asking. So I'm going to make that X. So I still need to figure out the predicted because I don't have that yet. So I'm going to go out to the side. Use my linear equation. Remember, this is how we get our predicted value. 2.29 times 600 minus 132.102. This is going to be my predicted value that I can then plug into that equation. So when I solve that, I get 1,241.898. So now I can come over here and plug that back in. What was it? 898. Can't read my handwriting. And then I have an equation to solve. Okay, so it's kind of like working backwards here. Instead of calculating the residual, I know the residual and I'm looking for the other pieces. So I would add 1,241 to both sides. And I get X equals 2246.898 grams. So this is how much it actually holds based on the residual and the predicted value. Okay, so the next part is going to take a little bit of time, unfortunately, but it's not too hard. It just kind of takes time. So we're going to add another column to our table, and we're going to calculate all of those missing residuals. Okay, so let's go up. I actually want you to add 2 columns instead of just 1. So I'm going to extend this here and then divide that in half. So we're going to add 2 columns. We're going to call this first column Y hat, and the next one is going to be your residuals. Okay, so you're going to actually calculate 2 more pieces. Remember our linear regression equation? I'll write it up here for you. 2.29x minus 132.102, hopefully. Yes, okay. So what you need to do is take your x values. Oh, goodness. We're going to use our x values here and plug them all into your equation. Okay, so I need you to do that first on your own to get all of the y hats. What you could do is type this equation into the y equals screen, like just when you're graphing the line, and use the table or trace button or the calculate button to plug them in, or you can just do them one by one. It doesn't take that long. Once you have all your y hats, your predictions, then you're going to calculate the residuals by doing the actual, so the 34 minus whatever you got here. So let me show you the first one. So for the first one, the y hat value is actually a negative 54.24. So the predicted amount that it held is a negative amount. So when I do my residual, doing actual, this is the actual number, minus the negative 54.24, and I get 75.24. Okay, so that's my residual. Actual minus predicted. Oh, all right, so take a minute, fill out the rest of this chart on your own. All right, so here is my filled out chart. I have all my predicted values, the y hats over here, and then all my residuals over here. I showed the work for that second one, and then the rest are just written out. This is negative 13.4. Okay, so you can pause if you need to check yours. If you don't have any, like if you made a mistake, just correct it so you have all the correct ones on there. Okay, so let's go back down to the questions. Let's see. So we did number 9. We calculated residuals. And it says, what is the largest residual, either positive or negative? So scroll back up. Okay, so looking at our residuals, it looks like our largest one, doesn't matter whether it's positive or negative, so look at the number. It's the negative 84.21. Okay, so, sorry, negative 84.21. The largest residual gives you the bounds for the maximum minimum the predicted values could be, right? So this number tells us like how far away from our residual will move in either direction. It's kind of giving us a range above and below the linear regression line. So it says draw a dashed line that is above and parallel to y hat. That is the same distance away as your maximum residual value. Do the same thing under y hat. An example is shown. Okay, so I'm going to just show you how to get those equations, and then we can draw them on the scatter plot. So this line right here, this is our y hat, our linear regression line. Okay, so for us, y hat equals 2.29x minus 132.102. What we need to do is just add and subtract the residual to/from the y-intercept. It's not going to change the slope of your line. You can see the picture here. All three of these have the same slope. So we're just going to add and subtract the y-intercept. So we have negative 132.102 equals, or sorry, not equals, plus negative 84.21. And then 132.102 minus negative 84.21. So this first problem, the addition, we're adding a negative. So we're actually subtracting basically. So we'd get negative 216.312. Sorry, I'm going on the graph. And the next one, we're subtracting a negative, which would become addition. And we would get negative 47.89. You can check these in your calculator as well. So our bound lines are going to be y equals 2.29x, so same exact slope, minus 216.312, and y equals 2.29x minus 47.89. Okay, so in this picture, y hat's in the middle. This bound line with the lower y-intercept is right here, so I'm going to call it number 1 just to make it easier. And this bound line's at the top. Okay, you can see on the image this vertical distance here. That's the 84.21. That's how long that little segment would be. Okay, so those two bound lines are kind of giving us our range. So, last question here. If the company made a 275 inch box, what is the range of the amount of cereal it could hold? So to figure out the range, we're going to do the same thing. We're going to add not or, add and, we're going to do both, and subtract the max residual from the y hat value for this amount. So that means we have to first calculate the predicted value. So 2.29 times that size box, 275, minus 132.102. Remember, this is our predicted value is using our linear regression, which equals 497.65 grams. Okay. So now to actually figure out the range, I'm going to do two problems. I'm going to take that predicted value, 497.65. I'm going to add, and then I set it up again. I like to just set up both because it's just easier. Subtract our negative 84.21. So this is our max residual, negative 84.21, and then I solve both of them. So for the first one, I would get 413.44. The next one, I got 581.86. So my range is 413.4 grams up to 581.86 grams. Now this last part, that's not a subtraction problem, that's like a range. Okay, so what this means is, like, if you were a part of this company and they asked you to figure out, okay, like, hey, we have a 275-inch box, how much cereal do you think it could hold? This is like a mathematical backing. You're not just guessing and saying maybe 400 to 500 grams. You're saying we've calculated it probably will hold somewhere between 413 grams up to 581.86 grams. Right? It's giving you kind of a range for prediction to help make decisions for the company. Okay. You will do more practice with this, so I'm actually just going to skip this next part completely because this video is super long. It's just a quick interpretation. So if you want to try it, great, but don't worry about it. You'll do more practice in the worksheets.